best educational experiences have really come out of, why are all my Docker containers failing? Oh, I ran out of disk space because I created a bunch of images and I didn't vacuum them.
Hello, everybody, and welcome to this episode of the Ampere Developer Impact. I'm joined today by Dr. RJ Nowling of the Milwaukee School of Engineering. I always have to remember what city the M stands for, RJ, MSOE. Thank you for joining me today, RJ.
Yeah, absolutely. I'm happy to be here.
So, the reason that we invited you to come along is because of the master's program that you organize for MSOE at the Dirk School of Engineering. You are the associate professor, and director of graduate machine learning programs. You run a master's in machine learning, and part of that master's in machine learning is a course on machine learning in production systems. Um, can you, before we get into why we've called you on, which I think people can
Yeah.
probably guess, can you tell me a little bit about the master's program and that specific course, the course for machine learning in production systems?
Yeah, absolutely. So, um, obviously there are many universities are now offering some sort of masters in machine learning or AI, something like that. Um, I think what separates our program is that we not only focus on like advanced modeling techniques, we also focus on how do you deploy and manage these models in a production environment. Because at the end of the day, a model isn't useful. It's just sitting on, your research cluster or such like that. You actually want it to be able to drive features within software that's
Right.
used by users.
Okay, and tell me a little bit about this is a master's program, so this is for people who've just recently graduated from an undergraduate, or is there also a continuing education professional development aspect to it?
A mix, actually. So, about half of our students are what we call early entry students. So, they're our own undergrads who decide to stay for an extra year. So, for 5 years to get a combined bachelor's, master's. But we also have been fortunate to have a number of professionals, working professionals from the local community participate in the program. And, some of them have 5 to 15 years of experience in positions like staff engineers or VPs of engineering. Um, and so, although it's a very technical program, we certainly do get a wide range of backgrounds.
Well, let's talk about some of the machine learning algorithms that you're teaching, like what's involved in putting together a machine learning production system. Like, how much of it is the model, how much of it is everything around it, how much is running on CPU, and how much do you need to run on GPU?
Yeah. So there are many different approaches to machine learning, right? And so my program and my experience are partially driven by what I saw in industry, working at a company that did real time online advertising. Um, and so the model itself actually is a relatively small part of the entire platform because you need to have continual data ingestion. You need to continually update data in a database because your prediction pipeline isn't just putting a vector of numbers into a model. You often need to query databases to pull in additional data in real time. And then you need to have logic for converting like traditional records into these vectors of numbers before you even send it to the model. And your model performance depends on not only the quality of that data, but the freshness of it, right? So when I was doing online advertising, we saw that like the 24 to 48 hours of uh, activity prior to the ad show were the most predictive. So in order to keep these systems relevant, you need to keep feeding them data. And so there's all that data infrastructure around it, as well as sort of adapting sort of continuous integration, continuous deployment approaches to the models themselves, right? So this is called ML ops, where you're
Right.
actually like retraining and redeploying models regularly because they drift. Um, and so in that class, the students build out all the components of this system. They deploy everything from Postgres to batch data pipelines. They train models offline. They deploy them as part of a RESTful service. They monitor them. They figure out that they're drifting, and then they set up like CI jobs to basically retrain the models on the latest data and redeploy them. And all of that is developed in and deployed to these virtual machines running on these Impure this Impure server we have. Um, All of our students have laptops provided by the university, and that's great, but spinning up and down the database and all the batch pipelines and all that stuff every time they come to class is going to rob them of the opportunity to see what happens. What happens if I, you know, don't implement this efficiently and suddenly I run out of disk space, or I have
Right.
a memory leak and I run out of RAM and I need to like fix it and redeploy it, right? And so the virtual machines allow them that experience of over the semester deploying these things and leaving them running and seeing what happens. And so
Okay.
some of the best educational experiences have really come out of, why are all my Docker containers failing? Oh, I ran out of disk space because I created a bunch of images and I didn't vacuum them, or
Right.
similar types of issues. Um, and so yeah.
Okay. So you brought in, thank you very much. The reason why you're on the Ampere Developer Impact. You're running all of the class laboratories for the machine learning and production systems on a single Ampere Ultra powered server. Is that right?
Yes, so we have two Ampere Ultra processors in it. It's a dual processor system with a total of 160 cores, terabyte of RAM, and probably like 30 terabytes of raw storage in a
Okay.
RAID array.
And is
And
that
so
is that
then,
enough computing, storage and RAM to run a class for like a production machine learning system for a class of how many students do you have in your class typically?
depending on the semester, I have between 20 and 40. And so I divide them into pairs, and then each pair is assigned a virtual machine. So we're easily running 20 virtual machines with 8 cores, using all 160 cores we have, some semesters. Um, and yes, I mean, they're running Postgres, they're running a batch data pipeline, they're running a RESTful service, they're running a CI job, they're running all these things within that virtual machine. Um, there are reasons generative AI is awesome and it can do amazing things, but it hasn't replaced all use cases of classical machine learning, in part because there's a lot of things that are very time latency sensitive, like real time advertising, where you need to run a model and get a result within 50 milliseconds, decide if you're going to show an ad to someone or not. Um, and so the memory advantages and the computational advantages of classical machine learning for fraud detection, like real time fraud detection. So like if they you try to purchase something and they say no, we can't, we run this transaction from running on your credit card, whatever. Those sort of things are very latency sensitive, and so uh, students need to know that about generative AI, but they also need to know about these other techniques too.
Okay. And everything is running in a single 8 core virtual machine, everything on CPU.
It
That's
is.
kind of amazing, because
Yeah.
the general impression that we have of AI is that everything must run on a GPU. You're showing
Yeah.
that you can run real life production systems without not with production workloads, right?
Yeah.
I understand this is an educational environment, but real life production systems on a relatively constrained amount of compute.
I think that part of that too is a lot of the companies who are innovating in this space, and using these things are massive scale, right? And the reality is that's only like 5% of companies. There are a lot of companies who, um, I'm just guessing here, but like Northwestern Mutual, the insurance company that's based here, have all sorts of, like, they have an online platform, right, for their customers and all these different things. And some parts of that platform, they need to perform these sort of real time checks and stuff, but aren't necessarily at massive volume for all aspects of it. And so you need to be able to scale these systems down as well as up.
Okay. Have you seen any issues with the software availability for the various software frameworks that people need to use as part of these systems?
No, it's been absolutely fantastic. So, I run Debian as the host OS, and I also run Debian in the virtual machines that I configure. I use Ansible to configure them all. And so I pretty much every Python library you can think of, the developers, either it's if it's pure Python code, it doesn't matter. If it's has a compiled component like NumPy or SciPy, the developers are still actually producing binaries compiled for ARM64, or it can be compiled on ARM64 with no changes, just like you would on an x86 64 system. So everything we use, whether it's the operating system, it's all the packages we use, because Debian has tons of packages, databases like Postgres, machine learning libraries like scikit-learn, they all work just absolutely without any friction.
That's pretty amazing. Um, can you tell me a little bit about after these students have completed their course, graduated? What would you say the industry impact of the course is? Like, for for the people who come in as part of their professional development, what do they bring back to their work? For the people who are
Yeah.
graduating as early access, what are their prospects in the industry?
I I think it helps to kind of have some context here. So, Milwaukee has a bunch of, 100-year-old companies that are heavily involved in heavy industry and other areas. And so they're not the East Coast and West Coast companies that are pushing the bleeding edge. They're adopting all of this and they want to have teams that do machine learning and incorporate it into all their products and services, right? Um, and so, in a way, we're ahead of the curve as a university providing that education. And so they're actually sending, so we have some of our own undergraduate students who stay for an additional year to get a combined bachelor's master's, which has been very favorable from a hiring perspective. I mean, our undergrads have a greater than 95% outcome, graduation outcome in terms of being hired. Um, and a lot of companies say, oh, yeah, we'll hire you after your bachelor's and we'll pay for you to complete the master's, because we see
Awesome.
these skills as valuable. On the other hand, we have people who have been working at these companies for 5, 15 years from a variety of levels, from senior engineers to staff engineers to even occasionally a vice president of engineering, who are basically coming to us and saying, okay, we want to learn all this stuff from you so that then we can lead innovative efforts at our company. And so they're actually using us to train their workforce. Um, to kind of develop that knowledge uh, rather than necessarily, having to figure it out all themselves.
And would you say that to what extent is the fact that they're doing all of these labs on an ARM64 server known to them? Is it an abstraction that like it's completely abstracted away? All of the software is the same on x86 or ARM64, or are they aware of it? And does it bring them a greater level of comfort doing this kind of workload on ARM? On ARM?
For the So I would say it depends on where they're doing development. I mean, I tell them certainly what system they're running on. Um, but what's interesting is if they do a lot of development within the virtual machine, they don't notice a difference, right? The few cases where students have explicitly noticed a difference is when they try to say they build Docker images on their laptop, or compile code on their laptop and then transfer it to the server, they realize, oh, it's a different architecture. So they either recompile it on the virtual machine, or some have even been, figure out how to do cross compilation and stuff. But generally speaking, it's showing these industry engineers, oh yeah, there's really no friction here. And so if we are looking at deploying something, we may want to consider these ARM-based, virtual machines or cloud systems, because they may offer substantial cost savings for us or density.
And you mentioned LLMs earlier,
Mhm.
and kind of large language models, and I know that you're adding a component or a course in um, generative
Yeah.
AI, right?
Yeah. So our master's program, we have three graduate certificates that students can earn along the way. One is ML engineering, which is this ML production systems class and a microservices and cloud computing class. TinyML, which teaches them digital signal processing and then deploying to microcontrollers, embedded systems, and then a generative AI production certificate that has a course in sort of under the hood of LLMs and a course we call LLMs in production. And so, thanks to the acquisition of two more Impure servers to support the generative AI production systems certificate, we're going to be able to show our students how to build these complex workflows that call out to LLMs, right? And what's really interesting is you know a large language model. There's challenges that people face along with the cost and the overhead of, because massive hardware requirements to use these things, but also from there they can hallucinate, or they can it's very difficult to determine when they give you a nonsense answer. because they're responding in natural language and such. So one of the things that we're seeing when we're talking to industry partners is that generally a lot of these workflows, rather than everything going to a single large model, general model, they actually employ smaller models that are fine-tuned for specific purposes throughout the pipeline that produces increases reliability, increases responsiveness, and it reduces hardware costs because they can be run on CPUs like the Ampere systems. Interact with the chatbot and it says, "What can I help you with today?" For as like a customer support agent. And if you say, "Well, I'm having technical issues with your website," or "I have an issue with my order," it tries to classify that. So then it then sends you down. It sort of forks and sends you to another set of specialized models depending on the type of problem you're having. And so we're seeing a lot of these patterns where these workflows are implemented from these smaller models. And
Right.
so using the Ampere systems along with the GPU cluster that we have, we're able to show the students how do you fine tune models on the GPUs and then deploy them on the Ampere systems, or how do you build applications that use different size models with those models distributed across heterogeneous hardware or things like that. And so it's absolutely amazing the things going on in this space,
Yep.
and we're so fortunate to be able to be able to give students these experiences.
It's fascinating, and I really like the way that you're using these Ampere systems to basically show how you can optimize and uh, minimize the cost of these advanced workloads. So, thank you very much for joining me today, RJ. The program sounds amazing. I feel like I want to go back to school now after hearing you present on it. Um, the program's amazing. We really appreciate all of the help all of the um, feedback that you've given us on your experience with the Ampere servers, and we look forward to a long and productive relationship.
Well, thank you so much for having me today, Dave.
And thank you, everybody, for joining me on this episode of the Ampere Developer Impact.